In this video, we're going to start looking at graphs of exponential functions. Now, the parent function of an exponential function is f of x equals b to the x power. Now, b can be any number. It could be 2, 1/2, 3/4, any number except 1. Now, depending on what this value is, you're going to get either an exponential growth or an exponential decay. If this value is bigger than 1, you're going to get an exponential growth that increases going from left to right. Now, if b is less than 1, you get an exponential decay, which decreases going from left to right. Now, in all exponential functions, there's also something called an asymptote. Asymptote. An asymptote is a line that the graph gets close to but never actually crosses. So let's take a look at an exponential growth function. 2 to the x power. And let's look at the graph of this. Now, you can see that it's an exponential growth like I showed here. But you might also notice that we don't see anything below the x-axis. That's because the x-axis is the asymptote of the line, and my graph gets really close to it, but never actually crosses. So, we've got an asymptote on the x-axis, and usually we use a dotted line to express this. And the graph itself does something like this. Now, domain, the extent of our x values, has no limit going left or right. It extends forever. So our domain is all real numbers. But my range is defined by the asymptote. Now, your asymptote is, in this case, y equals 0. Now, you can tell what your asymptote is just by looking at the graph. If there's no number added or subtracted outside, it's 0. So the line y equals 0 is your asymptote. Now, in this particular graph, all my points are above this line. So the range is y greater than 0.
Teachers, this is just a reminder that Ms. Dubo's baby shower is tomorrow. That's tomorrow morning at 7:45. And D105.
Alright, back to this. Now, the end behavior. Remember, this is talking about what the x's are doing, going from left to right. These are talking about the y's. What are the y's doing up and down? So, as x approaches infinity, that means as we go to the right, my graph is going up without limit. It goes up forever. So my y values, the f of x, is going to infinity. As x approaches negative infinity, that's going to the left, it's going down, but it's never actually going to cross and get past 0. Now, 1 second, please. Alright, sorry about that. Now, the y-intercept is a point. It's the point where your graph crosses the y-axis. So, it's the point where your x value is 0. And in this case, it crosses 0 at the point, I can't speak today. It crosses the y-axis at the point 0, 1. Now, this exponential function here will be an exponential decay because this value is less than 1. So, if I do 1/2 to the x power, we can see that it's very similar but goes the other way. I still have an asymptote on the x-axis where that's the line y equals 0, because again there's nothing added or subtracted outside, so it's equal to 0 here. And the graph itself does something like this. Now, just like the growth function I showed you, there is no limit going left or right, so the domain is still all real numbers. And your range is still y greater than 0, because all my points are above the asymptote. Now, one thing I forgot to mention before, these are just greater than, not greater than or equal to, because it's never going to actually equal 1. I'm sorry, never going to equal 0. Where did I get 1 from? Because what happens is your numbers get really, really small, because what we end up with is fractions. But as your bottom number gets bigger, it just really, all it's doing is getting closer to 0. Alright, now for the end behavior, as x approaches infinity, that's as we go to the right on the graph. And as we go to the right on the graph, my graph goes down and gets really close to, but never crosses, 0. As x approaches negative infinity, that means we're going to the left on the graph. It's going up without limit. So the y's, f of x, is going to positive infinity. Now again, your intercept, your y-intercept, is the point where your x value is going to be 0. And this one also has an intercept of 0, 1. Now, transformations of these functions are just like any of the other transformations we've done this year. Now, A is either going to be a reflection and or a stretch or shrink. So if we just have a negative out there, it means it's a reflection. If we have a number out there, it's either going to be a stretch or shrink, depending on whether the number is bigger or less than 1. And then if you've got both, well, that's two different transformations. This number here tells you your horizontal shift. Now remember that the horizontal shift is opposite of what you would think. So for instance, if I had x plus a number, it's actually moving the graph left. If it's x minus a number, it's moving it right. K is your vertical shift. And this one goes exactly the direction you would think. So if it's plus a number, you're moving up. Minus a number, moving down. And of course, K also helps you with your asymptote, because it's y equals whatever that number is. So looking at some examples here, this graph, the parent function was this. That's the parent function for this graph. And if we look at these, there were two transformations. The 2, that's a vertical stretch by a factor of 2. And the minus 1, well, that's moving it right 1. Okay. For this one, the parent function was f of x equals 5 to the x power. So anything outside of that is your transformation. So we have a vertical shrink by a factor of 1/3. The minus 4 here tells me it's moving right 4. And minus 2 here moves it down 2. Now, one thing to be careful of is on your base number here and here. It's your base number that determines whether something's a growth or a shrink. So here, the base number was 1/4. That means it's a growth. Some people get mixed up and they use the stretch or shrink to determine that, and that's not correct. Only your base number can determine whether something's a stretch, a growth, or a decay. So this one was an exponential decay. This one's an exponential growth. Another thing to be careful of is fractions don't automatically mean that it's a decay. This one is 4/3. That's 1.3 repeating. So it's bigger than 1, and it's an exponential growth. So for this one, we have 3 transformations. The negative there means it's reflected across the x-axis. The 2 means we have a stretch by a factor of 2. And the plus 7 means it's moving up 7. So let's look at some graphs that have transformations on them. So with this one here, I have 1/3 to the x power minus 2. And the graph looks like that. One moment, please. Now, in this particular graph, the asymptote is at -2. So somewhere down here, I'm just sketching right now. The line y equals -2 is your asymptote. Now, the graph is an exponential decay, so it ends up looking something like that. And again, I'm just sketching. If you were to actually plot points, you'd want to actually get the points and plot those. Now, the domain is still all real numbers because there is no limit going left or right. And your range, well, that's based on your asymptote. They're all above that line, so it's y greater than -2. Now for the end behavior, x approaches infinity. That's as we go to the right. As we go to the right, my graph is going down, but only till it gets to -2. So it's only going to -2. As x approaches negative infinity, that's going to the left. As we go to the left, my graph is going up without limit, so it's positive infinity. And of course, the point where it crosses the y-axis is 0, -1, so that's the intercept. Okay. So, let me go ahead and graph this next one. 1/2 times 3 to the x power, and then plus 1 here. And I'm going to go ahead and get my y-intercept. Now, sometimes when you graph these, you're going to get a lot of decimals. And that happens sometimes. So if you see a lot of decimals, don't let that freak you out. It happens, especially if you have a fraction for a vertical shrink. So here my intercept is the point 0, 1.5, and my asymptote is the line y equals 1. And the graph looks like that. So do my dotted line for the asymptote, and then my graph does something like that. Okay. Now, the domain is still all real numbers because there's no limit going left or right. And because my graph is above the asymptote, the range is y greater than 1. In behavior, x approaches infinity, that's going to the right. So as we go to the right, my graph goes up without limit. So that's going to positive infinity. On the other side, as x approaches negative infinity, that means as we go to the left, my graph is going down towards 1, but never past that. Now this one has a reflection to it. So, let me type it in real quick. So the difference here is that my graph is going to be upside down. Now the asymptote is at y equals 0 because there was nothing added or subtracted outside. The k value was 0. So y equals 0 is my asymptote. And my graph does something like that. Alright, so domain is still all reals because there is no limit going left or right. The difference on my range, though, is now my graph is below the asymptote, so I have to have my y less than 0 because it's below the line. Another difference will be on the end behavior. So as x approaches infinity, that means as we go to the right, my graph is going down without limit. Down on the y-axis is negative, and no limit means it's going to negative infinity. Now as x approaches negative infinity, that means as we trace the graph going left, it's going up, but only till it gets to 0. It's not going to go past that. And of course, the y-intercept is the point where it crosses the y-axis. It's also where your x is 0. So in this case, it's 0, negative 0.125. All right, so those are exponential function graphs.